Something that I have found very valuable for teaching is the use of something called a mastery assessment, or a mastery test or mastery exam. And I wanted to show you one example of that and give you an idea of how it's useful for assessing student performance and also for ensuring that they have the knowledge and the skills they need. What you're looking at is an example of a mastery exam. This one happens to be for a course on PLC programming. And the way the mastery exam works, they have a set of questions that the students have to answer with 100% accuracy in order to pass. They can't get a single thing wrong. If they don't pass this exam, they take a different version of it again and again if necessary until they demonstrate proficiency all the way through. So just to give you an example of how this might work, at the top of the exam, I have a table that lists the various questions on the exam. There's 7 of them together. What type of questions they are, and then what the student got in their first attempt and their second attempt. And they get 2 attempts in each sitting of the exam. So let's say on day 1, the student takes this exam, they answer all the questions, and they bring it up to the instructor for grading. The instructor takes a look at this, and if there's anything wrong with any of these questions, they'll put either 1 or 0 mark in the cell here. A 1 meaning they passed that section of it, a 0 means there's something wrong. For example, let's say if a student gets everything right except for some detail on question number 3, what the instructor would do at this point is put a 0 mark right there under the section questions 2 through 4, showing the student there's something wrong in there. But there's no hint given whatsoever. The student doesn't know what's wrong. They don't know which question the error is in. It could be in question 2, it could be in question 3, it could be in question 4, but they have to go back and check their work. And when they do that, they can bring the test back up to the instructor, and now the instructor grades the second attempt. Now, if everything is right here, all 1s, then the student passes the exam. But if there's still anything wrong here, the student fails the exam and they have to take another version of it on a different day. And that other version has 2 attempts, just like this one. So let's say day 2, the student comes along, they'll get a different version of this whole exam. Same types of questions, but they are randomized and made different, so they're not identical. And the student once again gets 2 attempts during that sitting to pass the exam. Now this is a really useful tool because it ensures at the end that the student really has grasped all of these concepts. It is important to make sure, as with all assessments, that this cannot be passed strictly with memorization. You have to demonstrate actual analytical thinking. That is very important. So demonstration number 1, question number 1, in this case is a performance demonstration. The student must actually wire up a PLC to perform a particular objective, and the instructor randomizes the results here, whether or not, which input in this case the start and stop switches are wired to, which output the relay is wired to, whether the PLC program needs to use a seal-in contact or retentive coils. And so the student doesn't know ahead of time exactly what they're going to be programming. They need to be familiar with how to do all of this and to be able to adapt to whatever the instructor might throw at them. Number 2, here's a wire sketching problem, where the student has to sketch the wires to the appropriate terminals to make this circuit work. And if there's a subsequent version, a different version of the exam the student takes, this will be different. Things will be switched around. Maybe we'll have a sourcing input instead of a syncing input card. All kinds of things can be made different. Over here, we have a PLC program, and the student is asked to determine the statuses of these 2 lamps, red and green, based on what's happening with the switches and the way the program is written. So they have to be able to interpret the program and follow through the logic. Here's another one. Here's a mathematical question where the student must calculate the horsepower output by a 3-phase motor given a certain amount of voltage and current, assuming 100% efficiency. Here's one where there's a fault review. There's a troubleshooting question on every one of our mastery exams where the student is given a presentation of a system. They have a certain wiring diagram. They have a PLC program in this case. Symptoms are described, and then the student has to choose whether or not each one of these faults is possible in its ability to explain all that's going on. So they have to independently consider each one of these possible faults and see whether or not it could account for what we see or whether it would not account for all that we see. And then, in some cases, these exams also have reviews, questions. For in this case, 240 and 250, those are different courses. So for students who have passed previous courses, they have to demonstrate that they still remember how to do certain concepts from those courses. And I've omitted that from this printout. I've just focused on the PLC questions today, but you get the idea. This has been a very valuable tool, like I said, for assessing student performance and also ensuring that they really have those concepts down. Because one of the fundamental rules of teaching is what gets measured gets done. If you are adequately and validly measuring student performance, the students will rise to the occasion. Now, as a matter of policy, I do not put any sort of a grade deduction on a failed mastery exam. Some instructors might do that. Depends how you want to run your course and do the assessments. My philosophy on this is because I am expecting 100% perfection on all of these answers, and students have multiple attempts to take it. I don't want this to turn into a punitive exercise. I don't want students to feel discouraged and punished if they continue to fail the exam for whatever reason, be it test anxiety or they aren't quite as strong on the concepts as they should be. I really want to ensure they have the concepts down. That is really the only objective of the mastery exam. It is possible to levy a certain deduction in score after a number of mastery retakes. You can do that if you wish, but I've also seen that decay into kind of a vicious cycle where the student gets even more discouraged and has even more anxiety when they take next versions of the exam. So my own personal policy is I do not deduct any points for failed mastery, but they do have to do it eventually to 100% proficiency before they can pass that course. So it is pass-fail in that regard. They eventually do have to demonstrate 100% proficiency. Anyway, it's been a valuable tool, and I want to share this as a tip for other teachers, as something they might want to incorporate into their own curricula as a way to evaluate student performance and to absolutely ensure that students are getting certain core concepts. So the objectives and concepts I have in these mastery exams are things that we have determined to be non-negotiable in terms of what the student really needs to be able to do to say that they have learned what they need to learn in a particular course. So no frills. It's all focusing on what's really considered to be absolutely essential.